Dear students, Physics second year, lesson 6, current electricity. Topic name is to determine internal resistance of a primary cell. Sir, what is mean by potentiometer? Potentiometer is a device which is used to accurately measure the potential difference between 2 points in an electric circuit. Potentiometer consists 10 meter length of a manganese wire is fixed on 1 meter length of a wooden plank between the terminals A and B in the form of 10 segments. Now this is the potentiometer diagram beta. Potentiometer is an electric device which is used to accurately measure the potential difference between 2 points. We have to determine the potential difference between 2 points in an electric circuit. Potentiometer consists of 10 meter length of manganese wire. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Potentiometer consists of 10 meter length of manganese wire. This wire is fixed on 1 meter wooden plank in between A, B terminals of the potentiometer wire in the form of 10 segments. Total 10 lines beta. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Definition for 1 mark. Working principle of potentiometer. The potential difference across any part of the potentiometer wire is directly proportional to that length when constant current is flowing through it. Here the potential difference across any part, total 10 meter length of wire is there na, any part. The potential difference across any part of the potentiometer wire is directly proportional to that length. If length is increases, potential difference also increases. Length is decreases, potential difference is decreases. Proportional symbol remove to, you will get constant, that is pi. Here pi is the potential drop per unit length of the wire. Pi means potential drop, drop means point. Potential drop per unit length of the wire. To determine the internal resistance is small r, external resistance is capital R. What we have to determine? To determine the internal resistance of a primary cell. Only one cell it is there. In previous topic, 2 cells are there. Here having of only one cell. As shown in figure, a battery of EMF is connected through a rheostat and a plug key K1 in between A, B terminals of a potentiometer wire. The circuit is known as primary circuit. Now this is the diagram of potentiometer as shown in figure. As shown in figure, let a battery of EMF epsilon is connected through rheostat RH and a plug key K1 in between the terminals A, B of the potentiometer wire. This circuit is known as primary circuit. In primary circuit, what are connected? A battery of EMF epsilon, rheostat and plug key K1 in between the terminals A, B of the potentiometer wire. This circuit is known as primary circuit. The given cell whose internal resistance R is connected to a resistance box and a plug key K2 at A end of the wire. This combination is connected to a jockey through a sensitive galvanometer G. This circuit is known as secondary circuit. The given cell whose EMF is epsilon, internal resistance R is connected to resistance box and a plug key K2. This combination is connected to a jockey through a sensitive galvanometer. This combination of circuit is called as secondary circuit. In this diagram, total 2 circuits are there. First one is primary circuit, second one is secondary circuit. In secondary circuit, what are connected? The given cell whose EMF is epsilon of internal resistance R is connected to resistance box and a plug key K2 at a end of the wire. This combination is connected to jockey through a sensitive galvanometer. This combination of circuit is called as secondary circuit. Now let us measure L1 be the length of the balancing point as AN1 with key K2 is open. Then we can write EMF directly proportional to L1. Proportional symbol remove to you will get constant, that is pi. EMF is equal to pi L1. This is considered as first equation. Now let us measure L1 be the length of the first balancing point as AN1. First we have to touch the jockey at various places on the potentiometer wire until the galvanometer can show to null or zero deflection. The galvanometer can show to zero or null deflection. We have to move the jockey on the potentiometer wire until the galvanometer can show to zero or null deflection. At the time of zero deflection or null deflection, the jockey choose the point is N1. Let L1 be the length of the first balancing point as AN1. L1 is equal to AN1. L1 is equal to AN1. You go A to N1. This is the first balancing point. We have to open the plug key K2. Now this time we have to close the plug key K2 and measure L2 be the length of the balancing point as AN2 by keeping a suitable resistance in the resistance box. The potential difference across the cell. Now let us close the, first we have to open the plug key K2 and find out the L1. Then we have to close the plug key K2 and measure the L2 be the length of the second balancing point as AN2. L1 is the first balancing point as AN1. L2 be the length of the second balancing point as AN2. A to N2 by touching the jockey on the potentiometer wire until galvanometer can show to zero or null deflection. Let us close the plug key K2 and measure L2 be the length of the second balancing point as AN2 by keeping a suitable resistance in the resistance box. Example: 1 ohm, 2 ohm, 5 ohm, 10 ohm, 20 ohm, 50 ohm, 100 ohm. Suppose we want 25. So in this having some buttons, these values buttons having, suppose we want 25, 20 plus 5, 2 buttons we have to remove. Suppose we want 100 ohm in the resistance box, only one button we have to remove in the resistance box. So by keeping a suitable resistance in the resistance box. Now let us close the plug key K2 and measure L2 be the length of the balancing point as AN2 by keeping a suitable resistance in the resistance box. The potential difference across the cell. So EMF place, you can take the potential difference V directly proportional to L2. Proportional symbol remove to you will get constant, that is pi. V is equal to pi L2. From equations 1 and 2 we get EMF by potential difference is equal to first equation right side pi L1, second equation right side by pi L2. Here what is cancelled? Pi gets cancelled. So remaining equation EMF by V is equal to L1 by L2. Now after cancelling, EMF by potential difference V is equal to L1 by L2. But EMF place EMF value, V place V value substitute. EMF is equal to I into capital R plus small r. V is equal to IR. Now this is Ohm's law. Ohm's law formula V is equal to IR. Sir, how are you getting, sir, EMF? By using of this formula, current I is equal to EMF by total resistance. I is equal to EMF epsilon by total resistance capital R plus small r, external resistance plus internal resistance. We want EMF. So do the cross multiplication. EMF is equal to I into capital R plus small r. You are getting. EMF is equal to I into capital R plus small r, and V is equal to IR. This is Ohm's law. Now substitute. EMF place EMF value, V place V value, substitute. EMF value I into capital R plus small r by divided by V value IR, substitute, is equal to L1 by L2. Right side is same. So in this, water cancels are I gets cancelled. Now denominator R divide with the two terms. First one is capital R by capital R plus small r by capital R. Separate it. Two values separate it. It is divided with R is equal to L1 by L2. Right side is same. Now capital R gets cancelled. So cancel to 1 by 1. 1 by 1 means 1 plus small r by capital R is equal to right side L1 by L2. Here plus 1 taken go to right side. Plus 1 taken go to right side, it is minus 1. Here capital R is dividing. Taken go to right side, it is multiplies. Multiplies with L1 by L2 minus 1. So capital R into L1 by L2 minus 1. Now R is the internal resistance of the cell. So the internal resistance of the cell is to be determined. Now we have to find out the internal resistance of the primary cell. So that is determined. Now attachment problem beta. Weightage is 2 marks. Topic is 6 marks. Problem is 2 marks. Total 8 marks. Question. A potentiometer wire is 5 meter long and a potential difference of 6 volts is maintained between its ends. Find the EMF of a cell which balances against a length of 180 centimeter of the potentiometer wire. Here what is given beta? Length of potentiometer wire. L1 is the first balancing point. L1 is equal to 5 meter and L2 is the second balancing point. L2 is equal to 180 centimeter. Centimeter to convert to meter, that is 1.8 meter. We know 1 meter is equal to 100 centimeter. So total 180 centimeter is there. So convert into meter, 1.8 meter. Here EMF of a cells are given. EMF 1. EMF of the first cell is equal to 6 volts, and we have to find out the EMF of the second cell. So comparison of EMF of two cells. Formula EMF 1 by EMF 2 is equal to L1 by L2. So what we have to find out? Epsilon 2 EMF of the second cell we have to find out. So taken go to right side. Right side L1 by L2 bring to left side. It is multiplies with EMF of the first cell. So taken go to right side. L1 by L2 taken go to right side. So EMF 1 as it is into this right side value taken go to left side. It is reverse. L2 by L1. Now substitute the values beta. Now substitute the values. EMF 2 is equal to EMF 1 multiply with L2 by L1. EMF 1 EMF of the first cell 6 volts into L2 second balancing point length 1.8 meter by L1 first balancing point length 5 meters. Meter gets cancelled. 1.8 multiply with 6. Suppose there is no point 18. 18 6 are 108. 108. So point after 1 digit. So point after 1 digit. So 10.8 divide with 5. Decimal form to convert as like a fraction form. So point after 1 digit na denominator plus 10 is add to 5. So 50. 108 divided with 50 you will get 2.16. So EMF of the second cell 2.16 volts. Thank you.